Hi, this is chapter 15, food analogs. So like I said in Google Classroom, we are going to be skipping chapter 14 and just going straight to chapter 15. This chapter is a 1-week chapter, and then we'll cover chapter 16 over 2 weeks. As I go through this, if there are sections of the book as well as ingredients that I completely skip, you are welcome to skip those as well. There are some points where I point some of those out. So just know that if I don't discuss something at all that's in the book, then you don't need to know it. If I do discuss it, it is worth your while to read that section of the book. So first we'll cover the functions of food analogs in general. And we've talked about food analogs before, but as a reminder, they are natural or manufactured, so they might be natural or synthetic substances that are used in place of traditional food products or ingredients. There are 4 general possible functions of food analogs. The first is to save money. We've talked about textured soy protein before and how it's used in hamburgers. And the reason that it's used in those hamburgers is because and one of the reasons I should say, is because it's cheaper than beef. So replace the beef with soy protein and save money. That same ingredient also changes the nutritive value. So textured soy protein is fat-free, it's cholesterol-free, and in the school lunch program, a lot of times they have like macro limits that they are trying to reach, then they're not supposed to have more than a certain level of fat. So they can reduce the fat by replacing some of the beef with textured soy protein. It also absorbs a lot of water, so it leaves the burger tasting just as juicy as beef. Food analog can also improve the performance of food or compounds within foods. So the example that the book gives, which is a really good example, is instant pudding. So typically, to make a pudding, you make a custard. And that requires a lot of effort, making sure that the eggs don't curdle, etc. You might also make a pudding with gelatin, in which case you'd have to heat it to gelatinize that gelatin and then let it cool down. Whereas instant pudding, you just mix it up. It's already been pre-gelatinized. And so it's much easier to make than any other form of pudding that you could do homemade. And so that is considered a way to improve the performance. The 4th function of food analogs is to taking the place of foods or food ingredients that are restricted for health reasons. And that's a main function that we're going to focus on in this lecture today, is analogs that are taking the place of an ingredient that is typically for health reasons. So these substitutes, which is a short way of saying that. Examples are artificial sweeteners, salt substitutes, fat substitutes, etc. This says skip, but it should say skip. And we are skipping the whole section that says pros and cons of food analogs in this chapter. So we'll start with sugar substitutes. And the main goal of sugar substitutes, they're depending on, I guess people have different goals for using sugar substitutes. One would be just to reduce your overall calorie intake, to still have that sweetness, but have less calories as part of your diet. Diabetics, of course, are much more sensitive to sugars than the rest of the population, and so reducing sugar can really help them out health-wise. And then a third possible goal for sugar substitutes are those people that are on low carbohydrate diets. And I put that separately from the reduced calorie intake because typically the people on low carbohydrate diets, they aren't just trying to reduce calories. They're specifically trying to reduce the carbohydrates because carbohydrates do have effects on insulin and hormone balance and inflammation in the body, etc. And a lot of times it's not even weight that they're trying to reduce, it's some of those other effects. The sugar substitutes can be divided into one of two categories. The first is non-nutritive sweeteners. These are sweeteners that don't have any calories that are contributed to the body. So sweet flavor is added without adding sugar itself or calories. The second classification of our sugar substitutes is nutritive sweeteners. And these are going to be the opposite. They do add calories, hopefully less than the sugar itself. So typically it's 1.5 to 3 calories per gram versus 4 calories per gram that is in sucrose. So the key thing here is that they can still contribute calories, and they can also still contribute to the glycemic load, which is a fancy way of saying blood sugar. Most of these nutritive sweeteners include the polyols, which are known as sweet alcohols or sugar alcohols, and we'll go through those. So the first non-nutritive sweetener is saccharin, and this is the oldest non-nutritive sweetener, oldest artificial sweetener there is. It was discovered in 1879, quite a long time ago, and saccharin is 2,000 times sweeter than sugar. So a very, very, very small amount is needed to add the same level of sweetness as sugar. At high concentrations, though, it can taste bitter. And so that is one of its drawbacks, is that it can taste bitter at high concentration. It's a limiting factor for its use. At one time, saccharin was thought to cause bladder cancer, and it was actually removed from the market. But unfortunately, there wasn't anything else that could be used in its place that was an artificial sweetener that diabetics and things could use, and diabetics and people who had issues could use. And so it was added back to the market, but there was a warning label that it might cause cancer. They did not know for sure that this caused cancer. They found an association in one study, and they removed it from the market just to be safe. Then they put it back with a warning label saying, we don't know, but it might contribute to bladder cancer. Since then, a lot of research has been done, and there's been no actual association with cancer that has been found. So it is completely on the market now, and there is no warning label on saccharin products. And where you've probably most commonly seen saccharin is in these little Sweet and Low packets. On a lot of these, I do have the chemical diagrams shown, and this isn't for you to memorize, but I just want you to kind of look at these. A lot of them look quite similar to sucrose. So sucrose, we have glucose, which is a 6-member ring, and fructose, which is a 5-member ring. Look, we have 6 carbon ring here, and a 6-member ring here. It's not 6, or not 6, 5. 5-member ring here. It's not 5 carbons because here's sulfur on one of them and nitrogen on another, but the shape kind of looks a little bit like sucrose. And that's not by accident. That has something to do with how the taste buds detect that taste and identify it as sweet. The second non-nutritive sweetener that we have is aspartame. This is actually made from 2 amino acids, aspartic acid, which we learned as aspartate in our amino acid chapter, and phenylalanine. And actually, this is phenylalanine. This is aspartate. And I do want to kind of side note here. So aspartic acid and aspartate, they are essentially the same. It's just aspartic acid has 1 extra hydrogen, and they go back and forth between aspartic acid and aspartate quite easily. It's just donating that hydrogen. Both of them are considered amino acids and considered the same amino acid essentially, but the name is different whether it's an acid and has that hydrogen or not. The flavor of aspartame, according to the book, is almost identical to sugar. I would beg to differ, considering I've never cared for the taste of diet soda at all, even when I drank soda, because it has a definite flavor. But that's what the book says. It's almost identical. I guess compared to a lot of other sweeteners, it's closer to sugar than others. Aspartame is 200 times sweeter than sugar. And I'm not going to ask you to recite for me exactly how much sweeter any of these are than sugar, but just be paying attention to the fact that most of these non-nutritive sweeteners are quite a bit sweeter than sugar. Aspartame, the key thing to know about aspartame is that it is not heat stable. So it actually breaks down at 86 degrees Fahrenheit, which means if you leave your Diet Coke outside in Texas in the summer, it's not going to taste like Diet Coke very much longer. It's not going to be sweet very much longer. And so because it's not heat stable, it can't be used in cooked foods unless it's been specially treated. So if they do specially treat the aspartame, then they can use it in cooked foods. But as is, in its natural form, no. Or it's natural, but in its native form, no. The third non-nutritive sweetener is acesulfame potassium, which is also known as acesulfame K. So K equals potassium, right? And this one is actually a salt. And when I say salt, it doesn't mean it tastes salty, but the salt means that it has these ions that make it up, okay? So you have a negative here and a positive with the potassium, and that makes up the salt. It is 130 times sweeter than sugar, and it is heat stable. Acesulfame K, I couldn't honestly tell you any specific foods that I've seen it. Actually, I've seen it in chewing gum. But the most common thing I've seen it in is tabletop sweeteners, the blue Equal packets. They are actually a combination of aspartame and acesulfame K. The fourth non-nutritive sweetener that we have is stepioside, also known as stevia. And this one is actually a natural extract. So this is the first one that we've seen that is natural and not synthetic, that is extracted from the leaves of the stevia plant. This sweetener is 300 times sweeter than sugar. I think its chemical structure is quite interesting because it's so different from the other ones that, I mean, it's massive compared to the other ones that we've seen. It is stable at high temperature as well as acid, so that makes it useful. And it's a relatively newer sweetener. It was approved for use in 2008 and has been on the market since then. Next non-nutritive sweetener is sucralose. This one entered the market in 1998, so a little bit older than stevia. We know it as Splenda commercially. And it's interesting because it's actually made from sugar. So this is a glucose molecule and this is a fructose molecule. So this is sucrose. And what they've done is they've taken 3 of the hydroxyl groups, 1, 2, 3, and replaced them with chlorine atoms. Sucralose is 600 times sweeter than sugar. And it's heat stable, very water soluble. It acts a lot like sugar, and so that helps with its use as a sugar replacement. I will say with sucralose, there is some recent research that shows that it might actually affect glucose metabolism, which it wasn't thought to before, and it may have other health effects. So it was thought that because of these chlorine, that the body just completely didn't recognize it and it passed through the body without being metabolized at all. And there's some recent research that suggests that that might not be the case and that it might have other health effects. Now, this research is conflicting, so this is the problem with scientific research is you'll have some research studies that say one thing and some that say the opposite. So there's some that say that there are health effects from sucralose, and there are some that say there are no effects from sucralose. And so there's been enough research showing that there's no effect that this hasn't been pulled from the market. And it may be the case that there really isn't an effect, and it just needs more research to conclusively say if this does have health effects. But it's something to look out for with Splenda and sucralose. Another one that is not in the book, but I wanted to include because it's becoming more popular, is monk fruit. Monk fruit is actually this little small round fruit that's native to China, and it is 100 to 250 times sweeter than sugar. So not as sweet as some of these, but still quite a bit sweeter than sugar. It is also stable at high temperatures, so that makes it a good sugar replacement in baking and things. And like I said, it's becoming more popular, so it's one to kind of look out for. Now we're going to go into the nutritive sweeteners. So these are the ones that are going to have calories associated with them. I'm going to cover mannitol and sorbitol together. So mannitol is 1.6 calories per gram and sorbitol is 2.6 calories per gram. Now these are 60% as sweet as sugar. So we have kind of a double whammy of things that are cons about these nutritive sweeteners. One, they have calories to them, unlike the non-nutritive. And two, they're not as sweet as sugar. So, for example, with sorbitol, it's 60% sweet as sugar and 2.6 calories per gram. So to get the same sweetness, I need to add 40% more of the sorbitol. And by the time I've done that, it's about the same calories as sugar. So that's something to keep in mind with the sugar alcohols, is that the drawback is that they have less sweetness than sucrose. Now, the reason that they are nutritive and that they do contribute calories is because they are partially digested in the small intestine. They aren't fully digested. The intestine is not able to digest them well and absorb them well, but they are partially digested. And so that does increase the blood glucose levels somewhat. So they're not completely ignored by the body, and diabetics still have to watch out for these, because if they do consume these sugar alcohols in high amounts, it can be just as bad as if they had consumed sugar itself. So whatever sugar alcohols are not absorbed and digested by the small intestine will then go through the large intestine. And at the large intestine, there are bacteria that do have the ability to break down these sugar alcohols. And when they do, they ferment them, and they produce gas. And so with the sugar alcohols, you do have to watch how much you consume, not only because of caloric content and blood glucose levels, but also because if you consume too much, then the effect of the gas production by the bacteria will be noticeable by your body, and you can have some discomfort with the bloating and potentially diarrhea from these products. So anytime that you have something that your body cannot digest, it can potentially cause some issues further down the line in your digestive system. So xylitol is kind of similar to sorbitol and mannitol, but it has one thing that I wanted to cover this separately for. So it's also a sugar alcohol. That all is a key there that tells you that's what it is, that it's going to be an alcohol. And it has 2.4 calories per gram, so kind of similar to sorbitol. However, it is 100% as sweet as sugar, so we can still maintain the lower calories and have the same sweetness when we use xylitol. It occurs naturally in small amounts in some fruits and vegetables, and actually the sorbitol and mannitol do too. Most commonly, I've seen xylitol used in sugar-free chewing gums, mints, and candies. Those are the most common things that xylitol is used for. I've seen before where it's been used in sugar-free peanut butter, and I don't think that's really much the case anymore, and I'll explain why in just a second. The nice thing about it being used in sugar-free chewing gum is xylitol can reduce tooth decay. Not only can it play a nice role in the fact that you have the sweetness, but the bacteria that normally would consume sugar and produce acid cannot process the xylitol. There's also some evidence that xylitol, as well as some of these other sugar alcohols, actually inhibit the growth of bacteria. So not only do they not give them food to grow, but they actually suppress the bacteria and decrease them. So they are actually pretty good in that role of preventing tooth decay. The big thing about xylitol is that it is toxic to dogs. And so what I was saying about the peanut butter is that there have been cases where dogs consumed xylitol laced peanut butter that was a sugar-free peanut butter and experienced some major disruptions to their system because of that, possibly even death. It's quite toxic to dogs. Like the mannitol and sorbitol, some of it is absorbed in the bloodstream. The rest of it goes through the intestines and is processed in the colon by those bacteria. And if you consume too much of it, you're going to have some discomfort. This one is also not in the book, erythritol, but again, it's one that is more popular on the market today, and so I've included it. So erythritol, as you could guess from the all, is also a sugar alcohol. It has much lower calories per gram than the other three that we've discussed, though, only 0.24 calories per gram. Unlike, well, let me get to that in a second. So it's 70% as sweet as sugar. It occurs naturally with the fermentation of fructose. So as fruits ripen, fructose does ferment some, and erythritol is produced. Unlike the sorbitol and mannitol and xylitol, it is absorbed fully into the bloodstream, but the body is not able to process it. And so it is excreted unchanged in the urine. It's not fully digested by the body. It goes into the bloodstream and then just out the urine. One possible negative of erythritol is that there are some studies that have shown that it might be associated with increased blood clots and those causing cardiac events. There's more research needed. I wouldn't all of a sudden not use erythritol at this point, but it's something to watch out for. So one thing that you should have noticed is that all of the non-nutritive sweeteners were quite a bit sweeter than sugar itself. And So if we're going to replace the sweetness of sugar, we're going to use quite a bit less of them than we would sugar itself. But the problem is that sugar has functions other than sweetness. It contributes body, it contributes color, the caramelization of food, the nice browning on the crusts of bread, for example. It contributes volume, it contributes texture to food. And so if we're going to substitute the sugar, we probably need to substitute the other things that provide these functions. We need to add something else to provide these functions, depending on what food we are substituting the sugar in. So like gum, okay, just add a little bit of xylitol instead of the sugar, that's fine. But for example, if we're talking about baked goods, this would be really important. The sugar adds a lot to those other than sweetness. And so in those cases, we're going to use what's called a bulking agent. And this is a substance that's added to foods to enhance the texture or thicken the consistency of the food. So some examples of ingredients that we use as bulking agents include polydextrose, maltodextrin. Both of these are starches, and they contribute calories and contribute to the glycemic load. So I'll say in the cases that these are used, okay, now you are a low calorie product and not a no calorie product from the sugar standpoint. Erythritol is also often used in combination. So remember, erythritol has 60% of the sweetness as sugar. So you add erythritol and then a non-nutritive sweetener that is much more sweet than sugar. And the bulk of what you're adding is erythritol plus this non-nutritive sweetener. And at that point, you can add erythritol and your non-nutritive sweetener, such as monk fruit, for example. Those are often mixed together. You can add those as a 1-to-1 ratio with the sugar that you would have added, and it works out pretty well. So let's move on into fat substitutes now. When we're looking at fat substitutes, we're going to have several goals. One is to replace the flavor of the fat, and then it's going to be to replace the function. So remember that fat is a stabilizer. It carries flavor compounds. It tenderizes dough. It adds texture to products. And so if we take out the fat, we need to be able to account for all of this when we substitute it with something. Starch-based fat replacers is one option. So starch can be milled very finely, and so in that case it can mimic the mouthfeel because that fine texture can mimic a greasy mouthfeel, but of course it's lower in calories. Carbohydrates have fewer calories than fat. So some examples of starch-based fat replacers are carrageenan. The book says from red algae. It's actually seaweed, not algae. Can help low-fat hamburgers taste juicy, so replace the fat with carrageenan. Carrageenan holds onto the water, and now you have the juicy texture of your hamburger. Cellulose gel is often used in salad dressing. In muffins and cakes, you'll often see applesauce or pureed prunes used as a substitute for fat. And how that works is that the pectin in those, because applesauce and prunes are both high in pectin, that pectin holds in the moisture and acts like a fat from a texture standpoint. Now, the applesauce and prunes would not work in flaky products because the fat in these performs a function other than moisture. So in flaky products, you have the crispness, you have the separation of the layers that the fat achieves, and that would not happen with the applesauce or prunes. You're going to skip protein-based fat replacers, but I do want to say from the last 2 chapters, because those actually have something to do with the starch-based fat replacers. So fat itself binds flavor compounds, and when you are eating something that has fat with the flavor compounds bound to it, you will gradually have those flavor compounds released from the fat and into your nasal passages, and you experience the flavor. If those flavor compounds are not able to bind to fat because you have a fat-free product that you're just using starch for example, you're going to get all of those flavors all at once instead of them gradually being released from the fat. And so you'll get those flavors all at once, and then after that, instead of being able to experience the flavor the entire time all at once and then bland. So that is a con of starch-based fat replacers. Also, something to look out for is that fat is flavor. And if you take out the fat and replace it with starch, you're not replacing the flavor. Carrageenan, cellulose don't taste that great. They don't taste like much of anything. So in order to replace the flavor, the main direction a lot of manufacturers have gone is replacing the fat with sugar. So you got all these low-fat products that came on the market in the 90s. Well, they just pumped those products full of more sugar to add more flavor so that people would still enjoy the flavor. So that's something to watch out for. Salad dressing is a big culprit of that. Is if you have a low-fat product, look at the calories, because the calories might be very close to identical because they've added so much sugar to make up for the loss of fat flavor. Finally, with fats, we'll talk about manufactured fats. And I'm only going to talk about one of them in this section, and that's Olestra. So Olestra is actually a sucrose polyester. And what does that mean? Okay, so we have this molecule here. It's a sucrose. You have glucose and fructose, okay? But what you might notice is a little bit odd about it is all these R's here, where normally there would be H's. Normally these are hydroxyl groups, okay? And what they've done is they've replaced the hydrogen and bound fatty acids where all these R's are. They attach a fatty acid to the sucrose molecule, okay? And the advantage of this is that you can have whatever fat properties that you want on this Olestra, and the fat's not absorbed by the body. If you want the consistency of a solid fat, then you add saturated fatty acids to where all these R groups are. If you want a liquid oil, if you're going to be frying and you want to use a liquid oil, then you put unsaturated or polyunsaturated fats on these R groups. If you have a certain taste profile that you are trying to achieve based on a fat that you would normally fry something in or add to a product, then you add those fatty acids to the Olestra molecule. And so this molecule will have whatever fat properties you want and whatever consistency and taste you want, just depending on what fatty acids you add to the molecule. So that's kind of cool. This molecule, this product was first developed in 1968, but they didn't actually get it onto the market for food use until 1996. They had lots of different ideas of how they could use it. They had millions of dollars worth of research put into it. lots of petitions to the FDA. Finally, in 1996, they had it approved. In 1998, Lay's Wow Chips were released, and they were great. They have the same flavor, texture, consistency as regular chips. They released them with both like Lay's and Doritos brand, and I believe Pringles had a brand too that also used Olestra. The problem came that, and from the very beginning they had to do this because of the previous research that they'd done, and they knew this about this product, is that the chips had to have a health warning label put on the bag that said this product contains Olestra. Olestra may cause abdominal cramping and loose stools. Olestra inhibits the absorption of some vitamins and other nutrients. Vitamins A, D, E, and K have been added. So let's go into why this warning label had to be put on. So similarly to the sorbitol, mannitol, xylitol, is that if a compound is not absorbed in the small intestine and it just goes through the small intestine into the large intestine, bacteria in the large intestine may be able to process it. And that is what happens. And so you have potential for cramping, gas, and loose stools from that. The second part of this is that when you have fatty acids here, well, fat-soluble vitamins are able to bind to them. And so you actually have the potential, because these fatty acids can't be digested, and there's no way to separate the fat-soluble vitamins from them before you reach the large intestine. And in the large intestine, nothing is absorbed into the body once it reaches that point. Then you actually have an anti-nutritive effect of this molecule, where if you have these vitamins just sitting in your digestive system, they could bind to the Olestra and not be able to be absorbed by the body. And so they actually added these vitamins as to fortify this product so that it was protective against your body losing these nutrients due to the Olestra. Now, people didn't pay a whole lot of attention to this second part, but this first part became this pop culture thing at that time. And it was this like running joke in the late 90s. There were skits on the Saturday night comedy shows, etc. And the phrase that ended up coming out of this, which is not part of the health warning label, but this is what people associated with Olestra, was anal leakage, which does not sound good at all, right? So these chips and Olestra had a really hard time overcoming this. And the reality of it is that if people consumed a regular serving of chips with Olestra, there were not these effects in general. If they consumed 2 servings, they didn't really have a problem. But if you had somebody, and I've known people to do this, like eat an entire bag of chips that had Olestra, they would definitely have these problems. But even without that, just the word anal leakage and this health warning label, it really kind of doomed this product from the start. So it didn't do very well. It did still stay on the market, but in 2003, the warning label requirement was removed, and it was because the makers convinced the FDA, like, hey, yes, if you consume more than the suggested amount, you could have these issues, but that's true for other things too that are natural, like fiber. right? If you consume way more fiber than you really should, you're going to have digestive issues as well. And so the warning label requirement was removed in 2003. And not surprisingly, shortly after that, they rebranded the chips because Wow had its reputation, and they rebranded it to Lay's Light, but still had Olestra in them. And they still didn't do that well. So all of this was finally went out of production in 2016, 2018. Today, there are 0 Olestra products on the market, and I know I've kind of skipped some of the products in here because they aren't on the market at all, and I've focused on ones that are, but I did want to cover this one because it's really just an interesting, important bit of history as it regards to food analogs and consequences of biologically how things work, as well as marketing and things. So this will be the last slide here, salt substitutes. And the reason that we would need salt substitutes is because high sodium intake is linked to high blood pressure, and many Americans' diets are too high in sodium. Specifically, Americans who eat a lot of processed foods, there's often a lot of sodium added to those foods, both in the form of salt and other ingredients. So if you are trying to reduce the amount of sodium in your diet, there are a few options. One is potassium chloride, and that is what this new salt is. This is pure potassium chloride. The only problem with potassium chloride is that it does have a slightly bitter aftertaste, and so it is limiting in how much you can use before you start to taste that aftertaste. You can use a little bit and it tastes just fine, but if you add a lot, you'll definitely taste the aftertaste, and it's not pleasant. This light salt is kind of an answer to that. It's 50% sodium chloride and 50% potassium chloride. So you can add more of it and you're still reducing the overall amount of sodium that you're adding, but having less chance of the bitter aftertaste with that. The second option is herb blends. So that's like this Mrs. Dash. And I should really have here herbs and spices. So you could use herbs or spices or spices. These are not technically an analog because they don't truly replace the flavor. Herbs and spices don't taste salty, but they do add flavor. And so that's why this Mrs. Dash is sold as a salt substitute. So that is it for our chapter on food analogs. This will be half of the exam coming up next week.